So instantaneous acceleration is what? Acceleration of a body at a given instant of time. So this can be written as instantaneous acceleration is the limit delta t tends to 0 delta v divided by delta t. Clear? Okay. So this can be written as A is equal to, so average acceleration changes to instantaneous acceleration when delta t tends to 0. That means when your time value becomes almost all tending to 0, that means very small interval of time, then the average value is considered to be a instantaneous acceleration. So we can write this as a dv by dt. This is instantaneous acceleration, and I can write this velocity as along x-axis and y-axis. Clear? So let us write this is change in velocity along x-axis and change in velocity along y-axis. I can write this as I cap and this is j cap divided by dt. So acceleration, instantaneous acceleration is equal to dv x divided by dt. This is I cap plus dv y j cap divided by dt. So rate of change of velocity along x-axis gives acceleration along x-axis. Rate of change of velocity along y-axis gives acceleration along y-axis. So this is our instantaneous acceleration. So in this case, if you want to write its magnitude is square root of ax square plus ay square. Then its direction is tan theta is equal to ay by ax. This is what we can calculate the instantaneous acceleration. Graphically we represent like this. This is ax and this is ay. Okay. This is your instantaneous acceleration. This is along x-axis and this is along y-axis, and theta is the angle between the resultant acceleration and with respect to x-axis. I mean horizontal component of acceleration. Acceleration is resolved into two components. Horizontal component of acceleration is ax and vertical component of acceleration is ay. Clear? So this is about what? Instantaneous acceleration. So it is very simple. Instantaneous acceleration is the acceleration of a given body at any instant of time. Like velocity we have taken. Anytime if you want to observe the acceleration of the body at particular instant of time, we will measure its instantaneous value. Okay. Then always you observe that we will take that average is changing to instantaneous. Either it is when we talk about the velocity, so there while defining instantaneous velocity we have taken average velocity. Average velocity becomes instantaneous velocity when delta t tends to 0. I told you the meaning is that when you are calculating or when you are measuring the value of velocity at a very small interval of time, at that instant, particular instant of time with a small interval of time, then average velocity becomes instantaneous velocity. Similarly here also average acceleration becomes instantaneous acceleration with delta t tends to 0. That means you are looking for the acceleration of a given body with a small interval of time. Clear? So always we say instantaneous value means at that moment what is the situation. So for example, I want to see at 10 seconds what is the corresponding velocity. That velocity is observed to be a instantaneous velocity, particular interval of time. Similarly, whatever the changes happens with a change in velocity, and that corresponding change in velocity gives corresponding acceleration at that particular interval of time. Clear? So that is called as what? Instantaneous acceleration. I hope you understood. So this is the formula we have to remember, and let us take an example to solve this, to understand this.